How do ML clustering algorithms see data shapes? Have you ever wondered how machine learning clustering algorithms interpret the shapes of data? It's a fascinating topic that reveals how these algorithms group data points based on their similarities. Let's break it down in a straightforward way. Clustering is a type of unsupervised learning. This means that the algorithm looks for patterns in data without any labels telling it what to look for. Each clustering algorithm has its own method for identifying shapes in data, and this affects how it groups points together. First, we have centroid-based clustering, like k-means. This method uses a central point, called a centroid, to representing each cluster. It calculates the average position of all points in a cluster. Data points are then assigned to the cluster with the nearest centroid, usually measured by straight-line distance. This method works best for clusters that are round or compact. However, it struggles with more complex shapes. Plus, you need to decide how many clusters you want beforehand, which can impact the results. Next, we have density-based clustering, such as density-based spatial clustering of applications with noise and ordering points to identify the clustering structure. These algorithms look for areas with a high density of points. They can find clusters of any shape, even those that are irregular or stretched out. They are also good at ignoring noise or outliers. Unlike centroid-based methods, you don't need to specify the number of clusters in advance. Then, we have distribution-based clustering, like Gaussian mixture models. These algorithms assume that data points come from a mix of different probability distributions. Each cluster corresponds to a specific distribution, which can take on various shapes, such as ellipses. This flexibility allows them to capture more complex shapes than centroid-based methods. Hierarchical clustering is another approach that builds a tree of clusters. It can either merge smaller clusters or split larger ones. This method can show different cluster structures at various levels. The shapes of the clusters depend on how the algorithm decides to group the data based on similarity. Lastly, there is affinity propagation. This algorithm doesn't requiring you to set the number of clusters. Instead, it allows data points to communicate with each other to find representative points for clusters. This can lead to identifying complex shapes in the data. These clustering algorithms are essential tools in artificial intelligence and machine learning. They help discover hidden patterns in data across various fields. For instance, they can be used in image segmentation, social network analysis, and recommendation systems. When it comes to tools like ChatGPT, DALL-E, and Midjourney, clustering algorithms can help organize large datasets. This organization makes it easier to generate content or personalize user experiences. For example, clustering user preferences can help tailor responses in generative AI models. Productivity plugins may also use clustering to group similar tasks, making it easier to manage workflows. Ethically, it's important to remember that the choice of algorithm and its settings can heavily influence the results. Misunderstanding how clusters are formed can lead to incorrect conclusions, especially in sensitive areas like healthcare or security. In summary, machine learning clustering algorithms see data shapes through different methods. Whether it is by looking at distances to centroids, local densities, probability distributions, or hierarchical relationships, each approach has its strengths and weaknesses. Understanding these differences can help you choose the right algorithm for your data analysis needs.